Hello, everybody.
Hello.
Yeah, I'm sorry. Last time, I was at the hospital, but now everything is okay now. So Sarah told me you went over the chapter. I think the first section of chapter 1. About some equations, right? So we're gonna see where we get, and then we're gonna continue from there. So I hope now everybody was able to access the Zoom link, right?
Oh.
All right, so good afternoon, everybody. Welcome to class. This is Dr. Ao. I'm sorry, we had a very hectic beginning of semester. I was like really in pain. I have to go to the hospital where I spent the whole day. But now everything is okay. It's not COVID. It's like, some belly pain, I'm feeling okay now. So, and Dr. Miller, Sarah Miller was very nice to substitute for me. So, but just to present myself, I'm Dr. Au. I've been with CCBC the last 7 years, I think. So before that, I was at Morgan State, you know, for 10 years. So I've been teaching math for at least 20 years now plus. So are we going to do 163 as, you know, Sarah went over the syllabus, so we know. I checked out the Alex roster. I think a lot of people are in Alex. You don't need the access code, right? You don't need the class code. You can access Alex through Brightspace. That is what you call the first day program, right? I think they include the bill into the tuition at a discount rate, okay? A discounted rate. So basically you would pay more if you go freely. If you go Alex and buy freely, you would pay more. Okay, so now for the knowledge check, you know, before Alex unlocks, you know, let me try to share my screen and go to. All right, so share my screen. All right, so this is you. So when you go to Alex right here, when you hit right here, you see. So for everybody, see, that is Alex, you know, I have 22 people, which is a good thing. So 22. So you have to do the knowledge check. Don't worry about getting right, okay? Don't worry about getting the knowledge check right, because as you know, as it says, it is called the knowledge check. They are trying to check what do you know or what you don't know, right? Of course, you know, Alex is something they try to customize everybody's objective. This is, you know, the idea behind Alex. They try to customize everybody's thing. You know, that is why do not like, you know, do not try to get the answers right in the knowledge check. If you don't know, just say you don't know, right? You can say you don't know everything, you see? So don't worry about that. So the objective, when you go to the assignments, you have objectives, see? And each objective has a due date, you see? So, and you cannot pass to the next objective until you finish that one, okay? So that is how Alex goes. So please try to do that as much as you can dislike it. You know, some people don't like it, me neither, you know. If you ask me if I like Alex, I will not say, I don't like Alex so much. So, but you have to look at always the grade, right? It is worth 10% of the grade, okay? If something is worth 10% of the grade, you cannot discount it. You cannot just, you know, put it like somewhere and say no, because, you know, if you let Alex go, then you are working on 90%. And if you're working on 90%, the best case scenario is to have a B if you are a very, very good student, right? So that is why I encourage everybody to put Alex in your, you know, your schedule. You know, I have like 30 minutes free time. I'll come and do some Alex. I have this, I have that. And then it does help you. It does help, you know. All right. So what Sarah did, so did she go with quadratic equations with you? Can somebody tell me?
I can't remember, maybe.
I think she went over
She
rational
started, but
equations.
she didn't. Yeah,
Okay, she went over rational equations.
Not all of them.
Okay, some rational equations, but not quadratic equations, right?
No.
Okay, Okay, so we're going to take it from there. So rational equations. So we're going to put some more examples. Okay, so like some basic one, you know, for instance, if you have 6 over x minus 5 plus 13 over x plus 2 is equal to 7 over x squared minus 3x minus 10. This is a typical rational equation, right? Very typical rational equation that, you know, probably you're going to have in the test or quizzes or something like that, right? So basically, I have to do something to get rid of the denominators, right? But before I do any of that, look at my expression, right? What do you think? What numbers cannot be solutions anyway? What numbers cannot be solutions anyway?
5 and 2, or 5 and negative 2.
Thank you very much. What would be the reason of that?
They are zeros.
Exactly. You see, 5 and negative 2 cannot be solutions because when you put 5 in the first denominator, when you put 5 here, you get 5 minus 5, which is equal to 0, right? And we know that a denominator cannot be 0, right? Because of that, I have to assume x cannot be 5 and x cannot be negative 2, right? So now, what you're going to do, the easy way to do it is to multiply each term by the least common denominator. Multiply each term by the LCD, the least common denominator. Now, how I know the LCD? Before I try to find the LCD, I have to factor this one. I have to factor everybody that should be factored, right? X minus 5 is in the final form, no need to factor. X plus 2, no need to factor. But this one, x squared minus 3x minus 10, how you factor it?
X minus 5 and x plus 5. Oh, plus 2.
X minus 5 and x plus 2. Usually the big denominator usually is a combination of the small ones, usually, right? Not every time, but very, very likely, okay? So now, because of that, what I say is my LCD. When I look at the 3 denominators, right? The first one, the second one, and third one, what I say is my LCD.
It would be x minus 5 and x plus 2.
Exactly. The least common denominator is the one that the smallest exponent that contains everybody. And here, of course, is x minus 5, x plus 2, right? That is the LCD, x minus 5, x plus 2. You see? So now, what is the easiest way to do this? In math, of course, in mathematics, we don't have always one way to do things. We don't. We have always a lot of ways to do things. But what is the easiest way to do that for a student is to multiply each term by the LCD. That is the easiest way to do it, right? Multiply each term by the LCD at the top. Multiply each term by LCD and simplify. You see here, I multiply by x minus 5 here, x plus 2, x minus 5, x plus 2, x minus 5, x plus 2. That is the easiest way to do it. Even visually, right? Even visually, this is the easiest way to do it. Now what you do after that, we simplify. The reason we do that is to get rid of all denominators. That is the reason, right? You see x minus 5 cancel out, right? Who's left? 6 parentheses.
6x plus 2.
Exactly. And then x plus 2 cancel out. What left? 13 parentheses x minus 5. On the right side, who's going to cancel out on the right side? Everybody.
All of them.
All
The
of
whole
them cancel out.
denominator.
Exactly. Who is left then? Only 7. Right? You see, when you do that, very likely you will have a very nice equation after that. A very nice one. You see? So, and now all of you know how to proceed is 6x plus 12 plus 13x minus 65 equals 7, right? And then this is 19x minus 53 equal to 7, which means I add 53 on both sides. I get 19x equal to 60. I divide by 19, I get x equal to 60 over 19. Okay, before I say this is my final answer, I have to always compare my answer with the other ones, right? I have to compare my answer with the other ones. With the two numbers we said do not qualify. You see, 5 and negative 2. I have to confront this number with 5 and negative 2. If I found those two numbers at the end, I cannot take them, right? So that is the easy way to do rational equation. That is the easy way to do it, okay? Find the LCD and multiply by the LCD, all right? So let me give you a couple of examples and then you try to do them by yourself. You got 2 over x minus 5 minus 1 over x plus 5 equal to 11 over x squared minus 25. And then five over m minus 2 equals 3m over m squared plus 2m minus 8 minus 2 over m plus 4. In both cases, I'm going to give you about 5 minutes to do them. In both cases, you factor what you need to, to factor. Then you multiply each term by the LCD. You do the simplifications, and then you try to see what you get. Okay, everybody, try to do that. Please.
Teacher. Sir,
Yes,
can I see the first example, please?
the first
Yes,
example.
yes, please.
Yes. Good. All right, so can somebody walk me over the first steps? I mean, the steps of the first one? Somebody,
Yes.
go ahead, walk me over the first step. What you did first?
So the x square minus 25. We'll do it in two parentheses, like x minus 5 and x plus 5.
Yes, factorial, right? Thank you.
Yes. You're welcome.
And then after doing that, what you say is a LCD then from here? What do you say is a LCD? After you factor the x squared minus 25, the LCD is what?
X minus 5, x plus 5.
The LCD is x minus 5, x plus 5, right? That is LCD. Now tell me what you did after that.
You will multiply the x plus 5 and x minus 5.
Like this, right?
Yeah. Per term, yes.
To everybody, right?
Mm-hmm.
And then you do the crossings, right? Everybody follows me? So you do the crossings, x minus 5 cross out, right? We have left is 2, we don't forget the 2, parentheses x plus 5, and then minus, yep, these two cancel out, the x plus 5 cancel out. Here, please do not rush, avoid mistakes. It's -1, parentheses x minus 5, right? And here, cancel out is
11.
equal to 11, right?
Yes, yes.
Okay. And then you are almost done, right? So
Just
if you avoid
multiply.
yes, distribute exactly 2x plus 10.
J plus 10
Mm-hmm.
my x
Minus x
plus 5
plus
Plus
5
5.
equal 11.
Thank you. So and then we have 2x minus x is x
X
plus 15
and
is equal to 11, and then just minus 15, so we get x equal to -4.
-4, yeah.
So is this number eligible? Is this number eligible to be a solution?
No.
Why not? Is this number -4?
This is not a real number, right?
It is a real number, right? So, but what I mean by that is this number, when you back substitute, do we get zeros in the denominator? We don't.
No.
What are the two numbers that when we substitute them, we get zeros in the denominator? What are those two numbers? What are the two numbers when you substitute them in the denominator, we get 0? One of them is
1 minus 1.
5.
One of them is 5. The other one is
-5.
-5, right?
Oh,
You see, these are the only two numbers that are not eligible to be solutions, right? Because when you back substitute them, you get 0 in the denominator. But -4 is not one of them. So -4 is a good solution. So I can take this one. How about the other one? So what did you find? What solution you found for those who did it?
M minus 2, M plus 4.
M minus 2, M plus 4. That is a factoring. Thank you very much. M minus 2, M plus 4. So what is the LCD then from there?
M minus 2 and plus 4.
Exactly, that is the LCD right here. And we're going to do the same, right? We're going to multiply by the LCD here. We're going to multiply m minus 2, m plus 4, m minus 2, m plus 4, m minus 2, m plus 4, right? And we're going to do the crossings. M minus 2, m minus 2 cancel out. We get 5, m plus 4. M plus 4 cancel out.
Mhm.
M minus 2, m minus 2 cancel out. So we got equal to 3m.
3m.
And here m plus 4 cancel out. We get minus 2 parentheses m minus 2, right?
Yeah.
If we do it right, our next
Yes.
step will always be an easy equation. If we do it right. Okay, so now we get 5m plus 20 equal to 3m minus 2m plus 4.
Plus 4.
Right? Yep. So we get 5m
Minus
plus
3m.
Yeah, minus 3m. Okay.
Plus 2.
5m minus 3m plus 2m.
Equals.
So we're going to do the same time, right?
Yes, plus 2m, right?
Yes, equal to negative 20
Plus
plus
4.
4. So we get, that is 4m is equal to negative 16.
And
We get
m.
m equal to negative 4. Right? So we get m equal to negative 4, right? Okay, so now
Yes.
what do you have to do about what you have to say about that?
It's not a good solution
Thank you very much. Why is that? Why is not a good solution?
because m is -4. -4 plus 4 is equal 0. So the
Exactly. Thank
the
you very much.
delimiter, we can say 0.
Thank you very much. That is not a good solution because it does make the denominator 0. It does make one of the denominators equal 0. So what is my overall conclusion to that? What I say?
No solution.
No solution, exactly. Okay, so that is examples of rational equations. Again, this is the easiest way to do it, right? This is the easiest way to do it. You may have some other ways, but this is the easy one, right? Okay. So after that, so we're going to talk, before we talk about quadratic equations, let's go quickly over what you call the complex numbers. Complex numbers, they are based on one number, which is called I, right, worldwide, such that I squared is equal to -1. We call that the imaginary number. I is such that I squared is equal to -1. Now, before this number I, was that possible? Was this possible to square a number and to get a negative number?
No.
That was never possible. If we just limit ourselves to real numbers, that was not possible. But you know, math is something that is very, very applied, right? So why we invented numbers, why we did that in math? We do that in math for practical reasons, because for instance, you are an engineer, you want to build something, you have some equation to solve, and your equations, they involve numbers whose square is negative, you see? Now, if you want to proceed with the research, if you want to proceed you have to invent those numbers. This is how math developed, right? So we invented new numbers. They are called complex numbers, and they allow that. They allow a number square to be negative, right? So I squared is -1. You see, what is another way to write it down? Or we can say square root of -1 is equal to I, right? Because before the complex numbers, we used to say square root of a negative number does not exist, right? We used to say that the square root of a negative number does not exist. But now it
When we
does
square,
exist.
when we square the root, we can cross the root and then it will be -1.
Yeah, yes, the root of -1 is I. You see, by definition. Okay, so it's not, you know, nowadays we adopt that. But when I was in school, we even didn't write square root of a negative number. We didn't write it this way. It wasn't very proper to write, okay? But now it is in the textbook, so we adopted that. But every time you have a square root of a negative number, it's going to involve I, every time, right? So, but you cannot let your final answer to be the square root of a negative number. No, you have to say what it means. For instance, if I do my problem, if I do any problem, I say x equal to square root of -4, I cannot stop right here. I have to say what that means. What is the square root of -4? What do you think it's going to be? What is it going to be? 2i. The 2 is for the 4, and the I is for the negative. It's 2i. You see? Don't stop right here. So what is the square root of -9? It's going to be what?
3i.
3i. Square root of -100?
10i.
10i, right? The square root of -5?
Would that be like a
Root
decimal
5.
number?
2.4i.
I root 5.
I root 5, thank you. You see, square root of 5 is not a number that we know exactly, right? Because we don't know exactly how much is the square root of 5, we're going to leave it like that, okay? Every time you don't know how much is the square root, you don't replace it with a decimal unless we ask you to do that, okay? If we don't ask you to do that, you leave it as is, which is the square root of 5. Now it's going to be the I square root of 5, or square root of 5i, like this. Tell me, for what simple, very simple reason, why we prefer this way of writing than this way of writing?
Organization.
Because of?
To organize like, you have to put the letters before.
You have to be the letters before?
You
Okay,
don't want to
so
multiply by a square root.
yeah, because mathematically these two are equivalent, right? We agree on that. They are exactly the same. There is nothing wrong to write the first way or the second way. But what is the advantage of the first way over the second way? Look at the second way right here. If I do this.
Oh, because when you take it out of the square root, you take what was it, like 3 square root 5 or 2 square root 5, you don't mix up the 2 and the I.
Exactly. That is you see right here. Look
Yes.
at this one. Look at this one.
It will be like root 5i.
Yeah, root 5i. Look at this one. Look at the way I wrote it.
It looks like you're multiplying.
Yeah, it looks like the I is inside, right? Okay. So that is confused. So that could lead to some confusion. Is I inside or I outside? To avoid that, we put I up front, right? That's it. That's the only reason. But both ways are mathematically equivalent. You see, this way has no confusion at all, right? For instance, if you want to write 3 square root of 5, 3 square root of 5, it's better to write this way rather than this way. Because when you write it this way, we don't know, if you're not careful, if you do this, we don't know exactly if 3 is inside or outside. That's it. That's the only reason, okay? So that's why every time we multiply, a square root by another number, we prefer to put that number up front, right? That's the only reason. So, yes. Square root of -7, how is it going to be then?
Square 7i.
I square of 7, right? Thank you. Etc. etc. So now from right now on, every time you see the square root of a negative number, you have to know there is an I coming out, right?
Yeah.
Or every time. So now what is a complex number now in general? A complex number is any number of the form A plus BI. A complex number is any number of the form A plus BI, where A and B are real numbers. Any number that can be written like this is called a complex number. Now, any number that you know on Earth is a complex number now, okay? You see here, I didn't put no restrictions on the A and the B. I just said A and B as real numbers, okay? So the A is called the real part of the complex number. And the B is called the imaginary part. You know, if you want to go with the vocabulary, okay? So if I got this, the number 3 plus 5i, is that a complex number?
Yes.
It is, right? 3 plus
Yes.
5i. Can we simplify it?
3 is real number. 5i is imaginary part.
Yes. Can we simplify this? Can we simplify it? Can we write it smaller?
Can I
There is
write it
no
what?
Can we you know, simplify it somehow? Simplify 3 plus 5i.
We
I
can
don't
say
think so.
3 plus 5 squares minus 1.
Yes, you see, I was asking this question just to let you know, there is nothing you can do. It's 3 plus 5i is 3 plus 5i, right? That is the final form of it, okay? You can, of course, nothing prevents me to write 5i plus 3. Nothing. Mathematically, these two are exactly the same. But for some reason, we just want to write it 3 plus 5i, okay? This is a complex number right here.
What's the reason?
No, there is no reason at all. 3
Oh, okay.
plus 5i and 5i plus 3 is exactly the same thing. Okay, so, but I said for some, you know, we prefer always to say A plus BI instead of BI plus A, okay? But this is exactly the same thing, all right? So -10 minus 7i is a complex number, right? The real part is -10, the imaginary part is -7. So now if I ask you this one right here, 20, what do you think? Is 20 a complex number?
No.
No.
You see, I was expecting that answer. But now I'm gonna ask you this. I'm gonna ask you why 20 is a complex number, why?
It's real number.
It is a real number, but why it is also a complex number?
Oh, we can say it's complex number. If we say that 20 by roots minus 1, okay, and the square like is 0.
Yeah, that is the idea, but less complicated than that. But that is the idea. Because why we say 20 is a complex number? Because we can simply add 20 plus what? 0i. Okay? Because 0 times I is 0, right? What is 20 plus 0 is still 20. So basically any number on the face of the earth right now is a complex number. So a complex number, we don't have to see I in it, right? Whether we see I or you don't see I, it is still a complex number, okay?
Okay.
So the numbers that that have I in them, we call them imaginary numbers, right? If a number has an I in it, we call it imaginary number. But all the numbers on Earth right now, all of them are complex numbers. Real numbers are complex numbers, right? Okay, so you see, if you look at in the offsets, we have this one is the real numbers, and then we have this one is the complex numbers. So complex numbers include real numbers, okay? So don't think it's going to be always only when we see I in it. Don't think that. Complex numbers include real numbers. Okay, so if we have a new set of numbers, of course we have to learn how to add them up, how to subtract them, how to multiply them, how to divide them. That's normal. Now look, if I don't know even what is I, if I don't know what is I, right? Can I still do 3i plus 5i, whether I know what I means or not? What is 3i plus 5i?
Wouldn't that be like 8i?
8i squared.
You see, you are overthinking it. What is the algebra rule in general? If you have a variable or a parameter, when you have 3i plus 5i, it's just 8i, right?
Yeah, it's just AI.
We don't need to know what I means to do 3i plus 5i. It's like 3 cars plus 5 cars, right? You see here, the definition of I does not play, okay? The definition of I here doesn't play. When we add complex numbers or we subtract complex numbers, we don't even need to know what I means. We really don't, you see? If I ask you to add these two numbers, add.
Okay, is it considered as a complex number?
Yeah, it is a complex number. If you say 2 plus 7i plus 9 minus 5i. Can you tell me, oh, I don't know how to do this because you have to tell me what I means? Is that a good answer?
No.
You see,
No.
do we really care about what I means here?
No.
We don't care. Because I know in algebra, there is a rule that say group the like terms, right? That rule is regardless to the variable you have. Group the like terms. I'm going to group 2 with what? 2 with 9,
Real
right?
number?
Yes, it's 11.
So
What is
could
7i?
That
Yes,
would
go,
be 2i.
go ahead.
Could you factor I with non-complex numbers?
Yeah, I mean, you can do whatever you want with the complex numbers, right? But that is way out of, we don't need that. We don't need to factor nothing here. That is just a regular addition. We just add them up. But if you wanna, if for some problems you need to factor I, you can factor I. I is just a number. See. So 7i minus 5i is what? 2i.
2i.
You see, again here, the definition of I is not in consideration here. I don't need to know what is I to do this. I don't need to know that, right?
Yes.
Just as for addition. For subtraction, for instance, if we say -3 minus 8i or plus 8i minus here, and 6 plus I. Again, do I really care about what I means here to do this?
What if I's so if you have -8i and 1i, what if you combine them and it's -7i?
Yeah,
Would that be
-8.
-7i squared?
No, just -7i, that's it. You see, when you combine when you add variables, does it change the power? The power doesn't change, right?
Yeah,
No.
the power only changes in multiplication.
Only when we multiply. When we add or we subtract variables, it never changes the power, never. So when you do 8i minus I here, it's going to be just 7i. That's it. Not I squared, right?
Yeah.
Okay, here. Can you tell me here? What is this answer? -3 what?
Negative 9.
-9, right?
Mhm.
And then
Plus 7y.
8i minus I. How much is
7i.
8i minus I is 7i. That's it. Okay. Again here, the definition of I is not in play, does not play, right? When the definition of I plays, when? When we multiply.
Yes.
You see, when we multiply now, for instance, if I have 2 plus 3i times 5 plus 7i.
It will be 3 like I square.
You see, okay, now here, I squared will come out. And since I squared comes out, we have to replace by with the definition.
-1.
Exactly. But first, everybody go ahead. Can you distribute this, everybody?
Sure.
You see, the distribution here, all of us know how to distribute. You see, it has nothing to do with I. Can you just do it normally as you distribute normal, normal parentheses? What you get? 2 times 5 is what?
10.
10. And then 2 times what? 7i. How much is that?
15i. Oh, okay.
14.
14i.
14i. And then 3i times 5 is how much?
15i.
15i.
15i. Okay, now comes the last one now. The
21i
last one
square.
now is 21
I square.
I squared. Never leave I squared not simplified. I squared is what?
Minus 21.
Yes, I squared is -1, right?
Minus
Because I squared is -1, this whole thing becomes -21. You are absolutely right.
Thank you.
You see, when you put I squared next to a number, it changes the sign, right?
Mhm.
That is the effect of I squared next to any number. When you have -6i squared, it becomes what?
+6.
+6. If you have 8i squared, it becomes what?
-8.
-8. Everybody see that? But when you change the sign, don't put the I again. No, the I is gone, right? So I squared is gone. So right here, now we're going to group the like terms. We're going to group 10 with what number?
-21 resulting in
-21, right?
-11.
Exactly. 10 minus 21 is -11. And 14i plus 15i is
29i.
29i. That's it. Okay. This is how we multiply complex numbers. Again, you distribute is something you can do. The only stuff you have to do is at the end when you have I squared to replace it with -1, right? All right, so let me give you some of them to do right here. 2, 3 of them to do. Everybody try to do that. Go ahead. I'm gonna let you do this and do. So meanwhile, you can write your name on the chat so I can take the attendance, please.
The weather today is done.
On the last one, is that a -5 or a +5?
Yeah, no, it's positive. It's 5 plus 6i and 5 minus 6i.
Okay. Did we just share our answers when we're done?
Yes. So I'm gonna ask some people to go to tell me their answers. All right. So the first one right here. What do you think is your final answer? Somebody.
26i plus 26.
26i plus 26. Everybody agree with that?
I got that too.
Okay. So it's gonna be 6
Yeah, I got that.
plus 30i minus 4i and then minus 20i squared, which becomes positive 20. So 6 plus 20 is 26, and then 30i minus 4i is 26i. That is right. The next one, how much is the answer?
1 minus 0i,
1 minus 0i?
which will be 1.
You think so?
I think.
Somebody has another answer?
-25i minus 25.
Negative 25i minus 25, right? So let's check that. This is 3 right here. Minus 4i minus 21i plus 28 I squared, which becomes minus 28. Okay, so 3 minus 28 is negative 25, and then minus 25i. Okay. See, I was suspicious. Why get 0i? This doesn't happen a lot. But the last one, what is the last answer? Somebody.
61 plus 0i.
61 plus 0i. Thank you very much. In the last one, there is no I. Okay. So again, let's do the math here. Is 25 minus 30i plus 30i. What happened to them?
The i's
They
cancel.
cancel out, right? And then minus 36i squared, which is plus 36. So basically my answer is 25 plus 36, which is 61. Look at all these examples. What is the only example that doesn't have I in the final answer? It's the last one, right? Do you see that the last one, what do you see as the two numbers? Don't they look alike?
They're square roots, or they're squares.
They are squares. They look alike. No, they're not squares, but you know, one of them
Perfect
is 5
square?
plus, huh?
Is it a
Reciprocal?
perfect square?
They are not reciprocal. There is another word for that, another math word for that. 5 plus 6i and 5 minus 6i, they are not opposite, right? They are not opposite, because opposite, you change all the signs. They
It's
are not
equals.
inverse. There is another word, I think you heard about it before. They are conjugate, right? These two numbers here, they are called conjugate, right? And every time you multiply two conjugate numbers, so 5 plus 6i and 5 minus 6i are conjugate. The conjugate of a complex number is when you change the sign in front of the I. You don't change the first sign, you change the sign in the front of the I. So the complex number a plus bi and a minus bi are conjugate. Okay? And when you multiply two conjugates, the final answer is free of I. Okay? The final answer has no I. So what is the conjugate of 2 minus 7i? What is the conjugate of 2 minus 7i?
2 plus 7i.
2
Or-
plus 7i, right?
Mhm.
You just sign, you don't change the sign other than the one in front of the I. What is the conjugate of negative 6 plus 3i?
Negative 6 minus 3i.
Yeah,
Exactly, negative 6 minus 3i. Okay? You
So
see, if, yes, go ahead.
directly the answer will be a square, b square.
A square plus b square. Yes, when you multiply them. So you do remember that. So even if I want to trick you, if I say 8i plus 9, what is the conjugate of 8i plus 9? What do you think?
good.
Minus 9 because it's times of 0i.
Negative 8i plus 9.
Oh, negative
You
8.
don't change the sign, only the sign in front of the I is negative 8i plus 9, right? The only sign we change is the one is the front of the I. Okay? So now what happens when you multiply two conjugate? What happens what you get? We don't have I anymore, right? So when we multiply a plus bi, look.
You'd
let's do
have
together.
a plus b squared, right?
A squared plus b squared. When you multiply a plus bi by a minus bi, let's do it together, everybody. What is a times a?
A square.
A squared. A times bi is negative abi, right? And then this one right here, BI times A is positive ABI. What happened to them? They cancel out, right? And the last one is minus B squared I squared. But minus B squared I squared will become what? Positive?
I square minus 1.
No, you see the I squared make it, so gonna make it plus, right? The
Yes.
final answer is A squared plus B squared. What we're saying here, every time you multiply two conjugates, if you make sure they are conjugate, you don't need to do the whole math. Just square the two numbers. That is your answer, okay? You don't need to do the whole math. Just make sure they are conjugate. For instance, if you do this, if you do 3 plus 4i times 3 minus 4i, are they conjugate? Yes or no? They
Yes.
are. Do I need to do the whole math?
No.
No.
I
What
square
is my
plus
answer?
9 plus 16.
9 plus 16. That's it. Okay? You don't need to do the whole math. But you have to make sure they are conjugate. Go ahead. Don't do the math. Just let me know what is the final answer.
One plus 1 squared plus negative 1 squared.
Which is what?
Huh?
Yes, which end up to be what?
Oh, 1 plus negative 1 plus I.
You see, you were in the right track when you say
It
1 plus
results in
negative 1
0.
squared. So you see, you find, so you have to know who is A, who is B. If you know who is A, who is B, you square A, you square B, and you add them up, right? So don't rush. Make sure who is A and who is B, right? So the first example, who is A?
1.
No, the first example, 9 minus 2i. Who is A?
9.
9. Who is B?
2, negative
2,
2.
right? Negative 2 or 2, right? Doesn't matter, right? So what's going to be my answer then?
85.
85, 9 squared plus 2 squared, right? You
Mhm.
see? My answer is going to be 9 squared here plus 2 squared, which is 85.
So would it be 0?
The last one?
Yeah.
Okay, you will say 0 if you involve I, but don't involve I. Who is A here?
1.
1.
1.
Who is B?
I.
No, the B is the number in front of the I.
Negative
Who is in
1.
front of I?
Out.
1.
1, right? You see? The invisible one, that is a B. Now, if I ask you now the question now, what's going to be your final answer? What you going to tell me now? Is it 0?
Oh, 2.
It is 2, exactly. It's going to be 1 squared plus 1 squared, which is 2. Right? So if you do the whole math, you're going to find the same answer at the end, right? But it's going to save us some steps. Now, after we do that, what is the only operation we haven't done yet?
Division.
Division, right? Okay, so look, for example, this number right here, okay, so you see this number right here, 3 plus 5i divided by 2 plus 4i is not in the form a plus bi. If I ask you who is a, you cannot tell. If I ask you who is b, you cannot tell, right? We have to do something. You have to remove the I from the denominator. For instance, right here, if you go to Alex and they say 3 plus 5i, they give you 2 boxes to put A here and another box to put B. Who is A?
3,
A. Who is B?
5.
5. If you have now 1 plus 3i divided by 2, who is A now?
1.
1.
Is it 1? Is it 1?
No.
You can break it down, right?
Half.
You can write this way. Who is 1? Who is A now?
Oh, 1/2.
1/2. Who is B?
3/2.
3/2, right? But if you have this, if you have 1 plus 3i divided by 1 plus I, you cannot say who is A, who is B until you remove this I right here. Okay? Is that clear?
Yes.
You see, if you have I in the denominator, you have to do something to get rid of that I so you can tell who is A, who is B, right?
Because, yeah, we can square it.
So right here, look at these examples right here. These 3 examples. Do they give you an idea what to do here to get rid of the I at the denominator? What can you do?
Return it to the form a plus bi.
Yeah, I mean, this is what I'm trying to
You can
do.
square it and get a negative number, then unsquare it, I guess.
Yeah, I mean, squaring it will not do it because it's going to transfer the I. But look at this right here. When you put a number next to another number, there's a particular number when you put next to it, the multiplication will have no I anymore, right? You see here is the denominator 2 plus 4i. What number can I put? What number can I multiply 2 plus 4i by?
2 minus 4i.
Exactly. That is the reason why we made all these examples right there, right? If I put 2 minus 4i next to that denominator, there will be no more I in it, right? You agree with me? So
Yes.
here you have to multiply and divide
Am I annoying?
by the conjugate of the denominator, which is here 2 minus 4i, right? So we have 3 plus 5i over 2 plus 4i. What we're going to do here, we're going to multiply and divide by the conjugate of the denominator. Okay? You see that?
Yes.
So now, what's going to be my new denominator? Do I need to distribute or what we did
Just
before?
a square plus b square.
That's it. A square plus b square. How much is that? How much is A?
4 plus 16 or 18.
It's 2 square plus 4 square, right?
Will be 18.
It's 18. No, it's 20, right? It's 16 plus 4.
Oh, okay.
Everybody agrees with me here? Why my new denominator is 2 square plus 4 square? For the numerator, I have no choice but to distribute, right? It's going to be 6 minus 12i plus 10i. And the last number, what you tell me? The last number, will it end up to be negative 20 or positive 20 after you simplify? What do you think?
Positive 20.
Positive 20, thank you. Because it is negative 20i squared when I there is going to be positive 20. Right? It's going to be what? 6 plus 20 is 26 minus 2i all over 20. You see, now I can tell who is A, I can tell who is B now. Who is A?
26 over 20.
26 over 20. Who is B?
Negative 2 over
2 over
20.
20.
Negative 2 over 20. Right? This is, don't forget this sentence. Do not forget this sentence right here. Multiply and divide by the conjugate of the denominator. That is how we treat these operations right there.
Can you scroll up? I'll just take a picture.
Yeah, I'm
please.
sorry. Yep.
Thank you.
So don't forget the sentence that says multiply and divide by the conjugate of the denominator. All right. So I'll give you another one here. Go ahead.
Done.
Okay.
All right, so everybody, so tell me what you did. You multiply divided by what number?
4 plus 3i.
4 plus 3i, right? And that is the only number that's going to work. The only number that's going to work is 4 plus 3i. If you miss that number, it will not work. What is my new denominator?
4 squared plus 3 squared.
Exactly.
25.
It's 25, right? And then I distribute the top, which is 4
20
plus
minus
3i
20.
minus 20i
Minus
Minus
15
15.
squared.
and plus 15, right?
Yes.
Which is 19 minus 17i all over 25. See, my A is 19 over 25, and my B is negative 17 over 25, right? So this is a summary of complex numbers. Of course, you know, it is a very, very large field in math, right? If you happen to do math a lot, you're going to see a lot of complex numbers. But here in 163, we just do some introduction to it. That's it. So we'll be able to use it. Okay. So when we come back next week, of course, you know, we're going to continue on reviewing. This is like a review. Okay. So everybody who did 083, I think they did that. Okay. So it's like a review. Next week, we're going to review quadratic equations. We're going to review some other type of equations, right? And the real 163 material will start with chapter 2, okay? But the whole chapter 1 is like a review, okay? All right, so.
Can I ask you a question, please?
Yes, go ahead.
So when I go to the Brightspace, I couldn't find the assignments or quizzes. So where are we gonna like?
Now the assignments, they are when you go to Brightspace right here and you go to Alex right here, this is where you find the assignments, okay? Brightspace, you go to Alex. Did you add Alex?
Yes, I add the class.
Okay,
on
this is
Alex.
where you got assignments, you see?
Okay.
Yeah.
I also had a question.
We don't have no other assignments, you know, other than Alex. Okay.
Oh, sir, you said for the assignment, we must go on Alex.
Yes, for the homework assignments on Alex. We don't have the only assignments beside homework we're gonna have is a quiz, but I think the first quiz we're gonna do is gonna be September the 15th. It's gonna be, I will post it on Alex, right? It's gonna be like some type of take-home quiz, okay? I'm gonna show you. I will post it on Alex. Open. For example, if you post it the 15th, I'm gonna leave you until the next day to bring it to submit it on Brightspace, okay? But the quiz will be timed. We're gonna do a little practice, you know, for that. I'm gonna post a little practice quiz, which will not count, but which shows you how to do that, okay? For the test, we're gonna do tests on Zoom. You see, for when you have tests, it's gonna be proctored. But the test is gonna be on Zoom. Everybody will turn their camera on. You're gonna adjust the camera for me to see the environment, and we're gonna see the test on Zoom, right? For the quizzes now, just to save us some time, we're gonna do that like some type of take-home quiz, okay? For the 2 week quizzes. But it's gonna be within the next 2 weeks, okay?
Okay.
Do the Alex assignments determine your grade or no?
Alex assignments, you know, they are graded, you know, automatically by Alex. You see, these are the assignments. When you go there, now the first objective is open. Section 1.1.2 is open until September 12, right? So
we can do that like more than one time?
yeah, the attempts, you have more than one attempt on Alex. Okay.
Thank you so much.
Sometimes if you do more attempts, it's gonna change the problem a little bit, but you have more than one attempt for.
Sir, please, can you give an example for how to go on Alex, please?
How to go on Alex? So
yeah.
What you do is when you go to your Brightspace,
yeah,
right? You click on the link Alex, go to content, and you click on this link right here. Okay?
Yeah.
And then you follow the instructions. This link will allow you to add your, you know, if you already have an Alex account, right? You just add the class. This link will allow you to add the class in your Alex account. So you don't have to pay, you don't have to do the class code, you don't have to do nothing. It allows you to add this class right here in your Alex account. If you don't have an Alex account, it's going to ask you to create one, right? Yeah, you follow that, you know, if you don't have, and then I did post, no, I didn't post that because it's going to be confusing. So just click on this one right here.
Can we leave now?
Yeah. The class is done. You know, you can leave, everybody. See you next week.
Thank you so much.
So follow everybody. So click on this link on Alex.
Professor.
Yeah, thank you very much. Have a nice day.
Yeah.
You see, when you go to content, when you go to your content, When you go to your content, you click on this one. You see the link?
Yeah.
This is Alex here in your content.
Yeah.
Yes. You click on it.
Okay.
And when you click on it, you follow from there. It's going to ask you if you have an Alex account, etc., etc. If you have an Alex account, you sign up, and then it's going to add this class directly. If you don't have an Alex account, it's going to ask you to create one. Okay.
Okay.
Very simple. You don't need no more, no class code. You don't need nothing else.
Okay.
All right.
Great.
All right. Thank you very much, guys.
Thank
Okay.
you.
Thanks.
Thank you.
Thank you.